Okay, now we'll deal with differentiation of exponential functions. Example. Now, I said before, we know how to differentiate x to the power 3. It is obviously 3x squared. This is when the power is a constant. Now, what happens if I differentiate 3 to the power of x? What is it? Now, we're going to learn this idea, all right, of differentiating 3 to the power of x. Now, very quickly, I'm going to just prove this idea. All right, very quickly, I'm going to prove that differentiate a to the power of x, we get this. Now, how do we prove this? There's nothing to copy. It's all given, but I'm just going to work it out so that we can all understand. Now, I'm going to get this idea. So I will first let y be equals to a to the power of x. Now, our objective is I can find dy dx. My job is done. Now, how I want to prove that obviously dy dx is this. Now, what do? First, we take log on both sides. And then power law will bring the x down. I'll get x log a. We all know implicit differentiation, differentiating both sides with respect to x, we will get a 1 over y dy dx. And ln a is just a number, it's just constant, I'll get x over there. Therefore, sorry, I'm talking about, there we get ln a. Silly. Alright? You get ln a. Alright? Ln a is just a number, I get ln a. Therefore, dy dx is y ln a. But let's recall what is y. Y is ax. Therefore, you will get ax ln a. Sure. So now we know differentiating 3 to the power of x, I'll get 3 to the power of x ln 3. Done? All good? All right. What if a is e? That means I differentiate e to the power of x, but e is a special number. You realize that you get actually ex, which is what you learn in O levels. Right? Why? Because ln e is 1. This is just a proof. Let's go straight to the one more thing, sorry. Now chain rule. By chain rule, now suppose I don't have a to the power of x. I need to differentiate a to the power of, say, x squared. By chain rule, we will be able, let me not use a, let's use 3 again. By chain rule, you have to let this be fx. There is one additional factor, which is f prime x here. That means you get 3 to the power of x squared. You still have ln 3. And this one, you need to multiply by 2x. This is f prime x. This is what happens when we differentiate. Got it? Okay, not going to say too much. Let's go straight to example 20. Example 20, what you need to do is to cancel all these away. Cancel all these away because there's a more direct method. And then cancel this line away as well. And then you look at this expression, y equals to e1 over x. What do we get? So you did this 1 over x, you can rewrite it as x to the power of minus 1. Minus 1. Minus 1. Correct? X to the power minus 1. So differentiating that, you get dy dx equals to e to the power of 1 over x. But you need to multiply by something, you get a negative x negative 2. Once you write that, the next line is out. Oops. Right? Next line is out. Okay, let's write b. be very clear here. This is your fx. So differentiating a to the power x, I get a to the power of sine inverse x times the ln a. Let's not forget, you need to differentiate this once, which is from MF15, MF26 formula list, you will get a 1 over square root 1 minus x squared. All right, then we will just, in the end, simplify. You will get okay. That's that. C is simple. You can do it on your own. In fact, C is simpler than B. B will just get this answer. Just write it out. You get 3 to the power 2x plus 1 ln 3 times a 2. Correct? That's that. Right, that's that. That's the end of the chapter. You can do tutorial 8 now.